Good morning and good afternoon and good evening to all my dear friends, students and participants. Welcome to this NPTEL MOOC course, the title of which is Application of Forecasting, Regression and Time Series Models. My good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, as you all know, the three main silos or three main areas for this course, which is spread over 30 hours, 60 lectures each week, having 5 lectures. So, we are in the 12th week, we will soon see. The three main topics are averaging techniques and forecasting, the second one is regression models and the third one is time series analysis. So, we are in the last phase, which is the time series analysis. This is week 12, lecture number 58, and the coverage for this 58th lecture would be concepts of stationary, non-stationary. We have done that, we will again revisit that, show that with further more runs considering different type of financial time series, because now the main focus would be financial time series. We will consider the concept of mean square error and find out the what are the concept of preliminary estimations concepts. Very briefly, the maximum likelihood estimation problems and example of ARMA PQ model. Now, for stationary time series, generally they are with the mean mu and autocovariance gamma in terms of values given as x n to x 1. So, we are basically considering all the data sets based on the present, and with the past data we are trying to forecast. So, if you remember till now all the analysis is based on and further on for the last 3 lectures would be how to find out the best fit model. And once the best fit model is found, then the later part is just forecasting and trying to find out the best estimate. And when you try to find out the best estimate, the main idea is to minimize the sum of the square of the errors, and we have been following this idea of trying to minimize the sum of the square of the errors from the first part, that is for forecasting we did, and obviously in forecasting there were other concepts of metrics also, the U statistics, the mod of the errors, mean absolute errors, then square of the mean absolute errors or the mean square errors, square root of that. So, there are different techniques. Then you have the percentage errors. So, those can also be applied here, but I am not going to go into so much details, because we have already covered a lot of concepts in all the 3 main topics, and the last one as we are discussing is the time series analysis. So, based on x 1 to x n, we want to basically predict the value for x n plus h. H is basically the lag, if you remember. So, the lags can be 1, 2, 3, 4, and depending on the lags, the concept of stationarity, non-stationarity, what is the best autocorrelation concepts, how you find out the lags, which is the best lag, or the partial autocorrelation, then the autocovariance, all these concepts we have already done. I will rehash it and revisit again. So, based on the values of x 1 to x n, we want to find out x n plus h is predicted by a linear combination of x 1 to x n, and 1 being basically when you are putting in the vector format, there is a constant also. So, the constant would be multiplied by 1, because that is why it is given in the vector formation. So, it is predicted by linear combination of 1 to x 1 to x n, which has the minimum mean squared error, and that will be denoted by p n x n plus h. And what we need to find out is basically the, which is of the form of here. So, a naught, a 1 till a n are the corresponding so called weights. Now, if you remember, these weights have been discussed in quite a lot of details in forecasting, and as I said, definitely I would have mentioned in some class, I do not immediately cannot recollect in which lecture, but I definitely did mention that the similarity and the relationship between forecasting and time series is much more, because regression would be a little bit different, while forecasting and time series are related. So, these concepts of A naught to A n are the weights, and if you remember also we have considered the sum of the weights is 1, and the weights are chosen in such a way we want to minimize the mean squared error. The coefficients A 1 to A n is determined by finding the values that will minimize the error, such that the expected value which you want to find out for the errors in the long run should be 0. So, if you can recollect, considering this slide has lot of information, I will still try to draw it. So, if we have, I will use a different color because all the colors are black. So, the y axis, x axis are given, and the time series is like this. We plot and find out the expected value, and the errors are basically the distance from the actual value and the predicted value, which is, I am putting a straight line. Obviously, for the non-linear regression time series also it can be considered that you fit out the non-linear equation, which we are not going to discuss in this time series part, because that will also take a lot of time, considering we have to go into much depth to consider that. So, the coefficients A 1 naught to A n, and remember A naught is with respect to the constant, because the constant is basically based on the population, and you also want to predict in the exactly the same way. If you remember, for the regression models we had beta naught, and beta naught was also required to be found out using the concept of beta naught hat. So, once the errors is found out, you minimize the error and find out the best fit model for considering the time series idea which you are proposing or which we are discussing. We assume that the data has been mean corrected by subtracting the sample mean. So, what we mean by that, I will go into this. So, this is the Excel sheet which I said we will be sharing. So, today we will consider another time series, and that would be with respect to the financial one, because now the emphasis is financial one. We are considering the DAX data, means the German index, and the prices are given in euros, and the dates are 2nd January 2025 till 19/6/2025. It is just a recent one. By the way, the URLs are given, and in actually if you want to find out the best price, best is to go to the official site, but I took this data rather than going to the nitty-gritties of the actuality of the data. If you have the data, it is best to utilize this data for our studies. And if you remember, we have done that in forecasting, we had done in regression models, and we are trying to do the same thing in the time series. So, if I consider the price in euros of DAX, so let me first plot it. So, if I plot the data, this is how the data would look like. Remember, I am only going to share the PPT slides in all the details and the data files which is in Excel, rather than saving all the graphs and all these things which we are doing, at least for the time series. So, because there are a lot of graphs which I am sharing or which I am discussing. So, people once they go, or the students once they go through the slides and also consider the Excel sheet and also see the videos, things and explanation and understanding for them would be much easier. Now, this is the time series which I have for the actual data. I am only taking the actual data. Now, I need to find out the mean. So, in the same way, I find out the mean, I mark it. Variance I need to find out, I mark with the same yellow and orange color, because that will keep the continuity, and the same type of coloring scheme I am using for all the different type of time series. So, there should not be any confusion. So, if I find out the average, so this is the average. If I find out the variance, you remember var p if we are considering the population, because there are the number of sample points is quite large. So, variability comes like to this, and the number of data size is about 169, which is quite substantial. Now, if I use, so let me copy this and take it to the top. So, that means we follow the changes as we make. This is the time series. So, done. Now, I mean corrected it. So, I find out price minus mean. So, this would be the price minus the average value. So, average value I will fix it giving the dollar sign. So, this is the data which I have. So, if you see the data as such, so there are two trends. So, technically there are three trends. First one, which I will mark as 1, is increasing slowly, then it dips, then the rise for the second one is quite steep, and the third one becomes much more level headed. That means, mean value seems, the change seems almost to be negligible, even though the values are quite high, but quick look at the diagram gives us the impression it is almost constant. So, if I plot it, so I plot the data for the mean, price minus mean, this is the value of the price minus mean. I will remove these set of information diagram which I was doing in order to show the three trends. So, this is the mean corrected one which you have. Then obviously, we have drawn the distribution. I am going to this other topic, distribution. For Bajaj, if you remember, for other time series data, here obviously, if I do the analysis, that would be repetition, I will not go. So, you can find out the R1, small r1 rate of return, then the logarithmic rate of return and the total rate of return. So, this is how the mean corrected value would look like. So, we assume, let me continue reading it, we assume that the data has been mean corrected by subtracting the sample mean. So, that is appropriate to fit a 0 mean ARMA model, because here in this case the mean value for the ARMA model which you are going to fit, we assume should be 0. The parameters to be estimated are the white noise. If you remember, white noise had a mean value of 0 and a variability of sigma square, and the parameters were theta 1 to q, because the parameter for the ARMA, considering there were basically two parameters, one was basically p and one is q. Q was based for the average, moving average. So, because we have subtracted the mean value, hence it is we are considering the average. We assume that the values of p and q are known and we can find it out. I will come to that, and how we find it out. Obviously, I have written some small MATLAB codes. I am not going to share the MATLAB codes, because they would be easily available once you do some preliminary investigation, because considering the MATLAB code and discussion will take a lot of time. So, I am going to come directly to the results. So, there are two ways of estimation: preliminary investigation, seeing the graph which we have just seen, and the maximum likelihood estimation method, which is a very strong and very popular and very robust methodology in statistics using the MLE method. We try to find out the estimates, and obviously, the properties of unbiasedness, consistency and other properties, once the estimate is found out using the MLE, would also hold like in other areas of statistics in time series also, but to test all these two properties on unbiasedness, consistency and further on, I am not going to go into the details. 4 techniques of preliminary estimation apart from the visual things can be done. So, you have to find out, one is phi 1 to phi p, the parameters based, if I consider the ARMA model. So, autoregressive concepts, parameter p and the moving average concept for the parameter q. So, you have phi 1 to phi p and theta 1 to theta q, and sigma square is basically the error which we have corresponding to the fact that the data set is x 1 to x n and the ARMA model is p and q. And we know that this backshift operator we have discussed in details, and with the white noise is 0 mean sigma square. So, Yule Walker estimation, one of the methods I did mention in the last class, how you can utilize the Yule Walker, I just mentioned it, Yule Walker estimation method to find out the variability. So, here there is Birch algorithm, the innovation algorithm and Hannon's resonant algorithm. I am just mentioning them, no need to go into details, because once you understand that, that will be more statistics and econometrics and time series, you can easily apply them using either R, Python, MATLAB or any other statistical software you may have. Now, considering the Gaussian likelihood concepts for the ARMA model, the likelihood function would be, so you have the likelihood function is almost looks similar to the likelihood function when you utilize for the simple normal distribution. So, sigma square is basically the error and the x bar j is basically the estimate of the mean. So, considering the maximum likelihood estimators for sigma square, which is given by sigma square hat, I will highlight it using the green color, light green, and based on that error we find out error, if you remember, the difference between the actual value and the estimated value, and square and then sum, and this is what we are doing. I will use the blue color to highlight it. So, here what you do, find out the differences and based on the number of readings you find it out. Now, here phi hat and theta hat are the values of phi and theta that minimize. So, based on that you find it out, and once it is found out, you use the some criteria which I will come to that very soon, AIC and BIC. So, these concepts of Akakai criteria and Bayesian criteria will give you the best estimate for P and Q. So, there are algorithms for that. Again I said the algorithms which I have discussed in the last slide would be useful to predict the find out first the estimates of phi and estimates of theta, because at the end of the day, once you find out phi and theta, your main focus is to find out the parameters P and Q. So, AICC criteria is given by this, we will soon see and utilize that. So, considering the moving average concept models, we will consider that there is constant volatility or unconditional volatility. Volatility is basically the variance. Volatility estimates do change over time, and that is very evident from the data. So, if you see the data, the variability, the mean difference. So, if I draw it, then in the next phase is falling, then increasing. So, the variabilities are, as the mean values are changing, also the variabilities are also changing. And that variability change is the main focus of time series, as I had mentioned. that we did not consider as an assumption in regression models. So, financial markets, as I said, main focus will be finance data. Financial market shows signs of autocorrelation. So, they are related to the past data. Financial markets also show volatility clustering, or volatility come in clusters, and that I will illustrate with a simple diagram. So, you can use autoregressive conditional heteroscedasticity arch models, and variance of Garch model also will utilize Garch, and what are the variants of Garch model we will discuss as we proceed. So, this is the ARMA PQ model considering only the sample autocorrelation function for the DAX data which we had from 2nd January 2025 to 19th June 2025. So, along the y axis you have the sample autocorrelation, and along the x axis you have the lags, and along the y axis you have the sample autocorrelation. This is the data which we just shown, and this is based on the financial time series only. Remember the actual price. This is the sample partial autocorrelation for the same data. So, you see the sample autocorrelation is fluctuating, and that had a steep fall. So, for the same time series, we will find out a P and Q, just hang on. Now, based on the concept of Akaike information criteria. So, what is that? It is an estimator of the prediction error, and we want to find out such that it gives the best goodness of fit for the statistical model based on the formula which is written. I am not going to the details, but I will only mention what are the parameters in the AIC. So, k is the number of estimated parameters which you have, L hat is basically the maximized value of the likelihood function for the model based on the parameters, and we will also use the Bayesian information criteria, which is a criteria for model selection based on this, where k we know, which is basically the number of estimated parameters we want to find out, L hat is the maximized value of the likelihood function. An extra term which comes is basically n, where n is the number of data points which is there. So, if you remember in the case of the DAX, you had 169 data points and n will be utilized accordingly. So, when I apply the BIC and the AIC separately and within writing a code and find out the optimum value for the ARMA model for the DAX, it comes out to be p is equal to 1, q is equal to 1. For the autoregressive process, parameter p is 1, moving average parameter is 1. So, this is important. So, these are the results applying the ARMA PQ based on the fact that I used AIC and BIC separately to find out and be sure the parameter values which we find out are matching, and there is no confusion in utilizing both AIC and BIC. Now, what we do is we change the track. We change the track in the sense, I will remove this diagram. This was the mean difference. I find out the log returns. This column AO is the log returns. If I click it here, is ln of P2 by P1. So, I can do that with R1 also, simple rate of return. I can do it with capital R also, but considering time series which I have mentioned, that we use the concept of continuous compounding interest rate. Based on that, we will be sure that we are using the logarithmic rate of return based on which we will do the calculation. So, the logarithmic rate of return are found out. So, let us find out the mean values. So, it comes out to be almost 0, that is 10 into 10 to the power minus 4, while variance comes out to be about 15 into 10 to the power minus 5. So, we have seen the same type of characteristics for the Bajaj data also, which was taken from NSC. which is Bajaj data is also there if you remember. So, based on these values, I need to find out the autocorrelation plots and the partial autocorrelation plots for the logarithmic returns. Let us go back to the slides. So, this is, if you read the heading, it will be clear. So, this is the sample autocorrelation function for ln of DAX prices. So, there is 1 day less, but still I have utilized the time frame from 2nd January to 2025 to 19 June 2025. So, you see the characteristics of the autocorrelation function. So, if I do and use the partial autocorrelation function, so it mimics so basically the maximum lag values which would be obviously for lag of 0 it is maximum, but very interestingly the lag values are basically almost like a sinusoidal wave. That means, there is positive and negative one, and which means the positive and negative one in the long run we think that they should neutralize each other to give a much more better result, and we will see that. Now, again we use the BIC and AIC for finding on the optimum parameter P and Q for the ARMA model but now for the logarithmic returns, and very interestingly the values of ARMA the autocorrelation value optimum value P is not anymore 1, it is 2, and the value for the moving average is also 2, Q is also 2. So, now we are much more certain that using the logarithmic one, considering the autocorrelation, partial autocorrelation graphs and using the BIC and AIC criteria to optimize, the best values which are coming out are P and Q both as 2. So, we will now go into the concept of introduction of Garch model. So, considering that I have spent a lot of time, I think I will postpone this concept of introduction to Garch model for the next lecture. Let me go back to the Excel file, which when I was doing the calculation suddenly an information came out very starkingly. So, if you find out the mean price minus the mean, which you have already plotted, very interestingly the value of the mean comes out to be almost 0. It is 7.47 into 10 to the power minus 12, which means that the mean corrected one would be in a way where the concept of stationarity seems to be very interesting one. Obviously, we will need to do the test, but I thought that I should mention that for the first difference. First difference means the mean difference, the actual value minus the mean, because considering we have already ran the arch model for PQ for the actual data, arch model for the logarithmic data, and the BIC AIC criteria is giving us good results. We can also do the same thing for the price minus the mean, that is mean difference, and we can generate the data, generate the partial autocorrelation graphs, then utilize the optimization tools and to find out the P and Q values. But I thought that I will highlight that the mean value is 0. So, coming back to the slides. So, considering we have almost spent about 30 minutes, I will postpone the introduction of Garch model for the 59th lecture and discuss correspondingly concepts there accordingly. So, sorry for that that this slides was just shown, but we will continue the discussion without breaking the flow of the discussion which we have for this course. Thank you very much and have a nice day.